And welcome to our review meeting, our first one in 2025. Today we look at a special release, which is 1.111. We have 4 presentations. Mark will start with a PR regarding the defaulting of the machine image versions. And we have Tim with the 2 changes in the Gardener operator regarding management of extension resources. Then Dimitar will show a new webhook for protecting secrets and config maps from being tampered. And finally, Oliver will show us some improved deletion logic in the node agent. All right, then Mark, please get started with the first topic.
Thanks, Raphael. Good morning, everybody. A quick disclaimer. So the feature I'm presenting has been implemented by Luca, but as he's currently out sick, I'm just filling in for him. So all credits go to him. Okay, what is it about? So the machine image version of the workers of your shoot cluster now have a fallback mechanism. So I'm using the provider local setup here. I don't have any shoots yet. And I have a few local Garden Linux versions in my cloud profile. So let's start first how you may be used to it. So I'm just creating a shoot cluster with a fully specified version. You see this is the 2.0 here at the end, which is supported in the classification. So if I apply that, all is fine. But now let's imagine that a security vulnerability has been found in this version and the operator is patching the cloud profile so that suddenly this version is now deprecated. And we're really unlucky because if we look in the cloud profile again, it just expired midnight last night. So if we now as a user again try to apply our shoot cluster template that we've always been using, suddenly this won't work anymore. But maybe I don't care that much about the patch or minor version of the image that I'm using for my shoot workers. So I heard about this new feature that there's now a fallback mechanism, so I want to use that. So I adjust my template and I just use basically the major version and the minor version specified in the template. I won't show the template now, but trust me that I put that in there. If I try that, it will be rejected again. So why is that? Because I specified the minor version to be 2, but as you can see, we only have the deprecated expired version with this minor version, so there's nothing to fall back to. So now I'm getting really frustrated. So what I will do instead is I will just say I really only care about the major version, so give me any version that matches this. This works, and we can also take a look at this machine. And I will have to search for a bit. So as you see, I only specified really the major version, but it automatically falls back to any supported version that fulfills basically this requirement. So it looked in the cloud profile, skipped the deprecated versions, and it found the supported version up here that it used instead. Yeah, what I can do as well is maybe let's do a successful example where I supply the minor version. So I will supply the minor version 5. And now I would expect that, again, it looks in the cloud profile. It will see that 5.0 is supported. Well, let's just see what happens. And we can take a look at the shoot again. Oops. Yeah, and it jumped to the patch version 1, which it found to be supported. Finally, if we look at the top of the cloud profile, so we see that we have the minor version 6, patch version 0 in preview classification. So we might want to try using this one. Again, we don't really care about the patch version, so we don't supply that. But in this case, it will be rejected since the version is still in preview and it doesn't find any version that's supported that it can fall back to. Of course, what you can still do, as you can do before, you can actively choose to use this preview version if you specify the version completely. So that works. All right, that's it. I suspect there won't be any questions, but if there are, let me know. And credits go to Luca.
Thanks, Mark, and also thanks, Luca. If there are no questions, Jan, you have a question, or did you just press the wrong button? Ah, okay.
No,
cool.
I have a question because obviously for us from Garden Linux, this is very interesting. I was just wondering, would it be not sensible to have a more automatic fashion doing this? Because when we do a minor release, does it not make sense that people get automatically upgraded to the latest minor version to simplify that process, and only when they have to can downgrade to the, let's say, last minor version they choose to? Because it feels like, yeah.
So, sorry for interrupting. I think I wanted to mention that and I completely skipped it. So this is exactly the scenario, right? So I have, well, how it is envisioned is that you have auto updates for your machine images enabled, which you can do either on patch or minor version. And then once there's new releases out, you don't really have to care about it, right? They will be applied automatically. Does it answer your question?
Yeah, thank you very much. Sounds good.
Awesome.
So I actually have a follow-up question on that, if that's all right. So you said during the presentation that it is a fallback to any version, but how I understood now, it's falling back to the latest supported version, or how is that mechanism working?
Exactly, the latest supported version, depending on what you specified, right? So if you specify the major version, that part obviously has to match. If you also supply the minor version, that part is also constrained, and that it uses to find any supported, non-expired, non-deprecated, non-preview version.
All right, cool. Thank you very much.
Just out of curiosity, if someone would be interested to say he wants to use a preview version, would that be still feasible?
Yes, that's basically, maybe that wasn't fully clear, but that was the last step that I showed. Okay, I think my memory of my machine is dying, so I will not share the screen again, but I chose the preview version explicitly the last time, so that is possible.
No, because I said no preview version, and I just want to make sure that we got this right.
Yeah, so for the fallback, it doesn't select it, but if you choose to explicitly fully specify a preview version, that works.
All right, then thanks everybody. And over to Tim for the improvements in the Gardener operator.
Yeah, hello everyone. I'm gonna show you two changes to enhancements to the Gardener operator in the extension space. So the first one is a new condition that the operator maintains for the extension resources. So on the left side, we have the runtime cluster where the extension resources are located. So I have this one for the provider local. And it has now the following conditions, or the following new condition. It has something called subtype required virtual. And this one gives operators a hint and an idea if the extension is actually currently used for something inside the virtual cluster, which basically means either for a seed cluster or shoot clusters mainly. So as we currently see, this one is reported as false, which would mean for operators, the extension can maybe even be dropped from the virtual point of view. So if you look at the right side, the Garden cluster, we can check out the controller installations. So there's currently one, as we have one seed cluster, but this one is, it is not yet required. So I faked this a little bit for the purpose of this demo, but it is just not being registered and not required for any shoot cluster on the seed. So, and this is then reflected also in the extension resource on the left side. So what we can do also for the purpose of this demo, we can patch that out. So we simply say that it is now required, which would actually be the job of the Gardener controllers to figure that out as soon as there's a shoot. So let's do this. Okay, it's patched. So let's check it out again. It's now reported as required. On the left side, the extension resource also reflects this one, saying the extension has a required control installation for seed clusters, and the status is now true. So it's, I think, a pretty easy way for operators to find out what the current status is about the extension, and it also becomes like the extension management becomes more and more centric in the runtime cluster. So before we had a lot of registration stuff happening in the Garden cluster with controller with controller registrations and deployments, and now we're shifting that into the runtime cluster. Okay, so this was the first enhancement, and the second one is actually an enhancement that you can now register generic extensions for your runtime cluster. So what that means is before this change, a extension in the runtime cluster was mainly responsible for, or the use cases were mainly that it takes care about backup buckets and DNS records for the Garden cluster. And now you can use the very same mechanism to register any kind of extension that does any kind of things with the runtime cluster, whatever that might be. We can talk about that idea maybe after the demo. But let me first show you how this works. So the very same extension that I already showed you, the provider local, it also has something in the resources, which is of kind extension. So this is the generic way of handling that stuff. And the type is local extrude, can be any kind of type as you wish, but the local provider is responsible for this type and registers this type. So what this actually means, or what this meant earlier, is you can of course have a shoot cluster that defines this extension in the shoot specification. It gets the extension and so on. And now this is only also possible for the Garden resource. So what you can do is we can edit the Garden resource. There is a new struct in the specification called extensions, so very similar to what is in the shoot API. And we can like use this type. Okay, we save it. We wait for it to be reconciled. Just give it a second. Shouldn't last too long. Okay, it's already waiting for the extension resource to get ready, and it's done. So what happened behind the scenes is we have a new extension resource, and this is an extension resource of another group. So don't get confused with the extension resource from the operator API group. So there's also this API group, right? It's called extensions Gardener Cloud. So the operator created this object. It has a very low specification for the local case. The local provider maintained the status to be succeeded so that the reconciliation can go on with the Garden resource. And basically it means that we now have this extension for the runtime cluster as well. As I said, the local case is more or less a fake, so it doesn't do much in this case. What we envision for extensions, for generic extensions to do is, for example, if you take the shoot search service, which is currently only responsible for shoot clusters, can also be handling the certification stuff for the Garden cluster. So for instance, looking at the Garden resource, automatically requesting certificates for a specific provider, for specific endpoints, patching the Kube API server deployment with the SNI certificates that are relevant. So all of that stuff can then happen automatically with the help of the extension. So this would be one example. Another example would also be something like audit logging. So the audit logging extension or any kind of audit logging extension could be written to also take care about the runtime cluster, registering audit log endpoints for the Cube API server, also patching this deployment again. So it's, as I said, it's very generic. I think use cases are endless and still a pretty unified way of registering extensions for the runtime cluster or for the Garden cluster, as well as for the shoot clusters themselves. So still as I said, a unified way of handling stuff. Okay, that's basically it for the demo. Please go ahead if you have any questions. Otherwise, thanks for the attention.
No question, but nice improvement. I like the way how similar the extension handling is between garden object and shoot object. It makes a great experience from my point of view.
Yeah, thank you very much.
Okay, all right. Thanks, Tim. Then let's continue with our next topic, which is presented by Dimitar and about the secret and ConfigMap tampering protection.
Hello, everyone. I hope you can see what I'm sharing and also hear me well. Today, I will present this small change that concerns the Gardener admission controller. It basically implements a new validating webhook that aims to prevent tampering with secrets and config maps that are stored in the projects of Gardener stakeholders. And the target secrets and config maps for this feature are such that we may consider system and are kind of sensitive and should not be modified in any way. Just to give you an example why we want to do this. Some of you may know that we now have this component called Gardener Discovery Server, which it serves the purpose to serve OpenID discovery documents of a shoot cluster outside to the public internet. So basically, it skips authentication and authorization and serves them freely. This is in order to allow establishing a trust connections to specific shoot clusters from the outside. And this is done by third parties. So what is the risk here? Basically, if we look at this picture, here we have the discovery server component, we have the garden cluster on the left, and we have a project namespace, and this is a user that has some permissions to that namespace. And what happens if we store this data here in the namespace of a project? Then basically a malicious user can, for example, generate its own private public key pair and inject that into the config map or the secret that we serve to the outside. So this will result in, for example, if a third party is requesting a discovery document for a shoot cluster, then the discovery server has no way to determine if this is tempered or not, because it's really just a simple component that reads the data from somewhere and serves it to the outside. So this can result in user impersonation and other bad things. So what we did to prevent that was basically create a new namespace in the Garden cluster that we call Garden System Shoot Issuer. And this namespace was created for the sole purpose of storing these shoot discovery documents in it. And yeah, we basically rely on role-based access control so that users who do not have access to that namespace cannot tamper with the information that is stored there. Yeah, this was the first use case that we wanted to do, basically the discovery server serving these discovery documents, but then we also wanted to serve the CA bundles of the shoot clusters because these were not available without authentication and authorization. So basically, if a user wants to create an OpenID Connect kubeconfig for a set shoot cluster, and that config does not contain any credentials or secrets, the user must still have access to the Garden cluster, so it fetches the CA bundle from a config map that is stored in the project namespace. So we first thought that we might introduce a new namespace here, but that would mean that we would duplicate data between the project namespace and then this other system namespace. So what we decided to do was to introduce a new webhook, validating webhook in the Gardener admission controller, which should aim to protect such resources that should not be tampered by users. So now when the Gardener discovery server can read these CA bundles from the project namespace, and yeah, this can be considered safe because we now have validation, and these CA bundles cannot be modified. Maybe in the future we would also like to migrate from that shoot issuer namespace and move these discovery documents also in the project namespace, but that should happen after a discussion, because storing these in the project namespace will also affect existing quotas for config maps. Okay, and yeah, I have prepared a really short demo. Basically, I have a local setup with a shoot cluster in it. If I want to delete this local CA cluster, which contains the CA bundle of my shoot cluster, then I get denied this request because this is considered system resource. I can get it, and that's okay, but I cannot delete, create such resources or update it. And how we can achieve that? The only thing that needs to happen is that we need to label such config maps and secrets with this Gardener update restriction label, and the webhook will pick it up and validate such operations. As of now, the only user that can update such resources is the gardenlet, or are the gardenlets. And the other thing that can delete such resources is the garbage collection controller of the kube controller manager. This is because we here rely on owner references for these resources to be cleaned up. So yeah, we also had to allow the KCM to perform the delete operation. So this was pretty much it. If you have any questions, please feel free to ask them.
No questions? And thank you, Dimitar, for the presentation. And over to our last topic for today, improved deletion logic in Gardener Node Agent, presented by Oliver.
Hey, good morning. Yeah, I like to present a short improvement because we found a bug in the Gardener Node Agent, and this bug leads to a situation where the Node Agent deleted too many files of systemd units or drop-ins in under certain conditions. Yeah, I prepared a short demo to show this. Yeah, here it is. Yeah, this is not a live demo. I recorded it before because it's not enough time to. So 2 demos. It's the status quo. So I like to show you what happened before the 1.1.1 release. Okay, basically we start with a shoot. It's a fresh shoot, just created, and I logged here into the machine of this local setup and showing the content of container D service dropped in. And basically, yeah, in the beginning, there's just one file. And to create my demo case, I kind of adapted the provider local, and I updated the OSC handler here to add a drop-in for container D. Yeah, the content doesn't matter, so it's just a file. Okay, back to the demo here. So suit was reconciled, and the new status is that we have this ergs, this file created by the provider local webhook added. It was added to the operating system config by the webhook and applied by node agent to the host. And yeah, finally, I also created an own file in the container D as a drop-in for container D. And yeah, in the end, before we start messing around with this node, we have this situation. We have 3 files. So basically, this was the file which was already present. There's one file created via operating system config and one file which was created by me. And what I did now is I removed this this add-on file here, this one from provider local again, so that provider local does not add any file anymore, and reconciled the cluster again. And you see what's happened. Has happened. The entire directory was gone. The reason for this is that we have in the operating system config, we do not specify any container D unit. It's available on the system. It's default unit by the operating system, and we just added one drop-in. So basically, this is the only occurrence of container D service in the operating system config. And when this was removed for the Gardener node agent, the entire unit was removed, so it deleted everything. And that's obviously not a good situation, but the good thing is we fixed it, and I can show this in a live demo, I guess. So here, basically, I updated to the 1.111 release, and I have a node shell here to the node. It's the same node, and the status quo is like this status here, where this drop-in unit was added by the provider local, and maybe I can do the same thing here and add my my own file. Okay. And now the short demo starts. Basically, we can kind of watch the contents here. And I already prepared the cluster that this drop-in is removed again. So all I have to do is to annotate the shoot to create a fresh operating system config. Okay, it takes a while until operating system config is created and taken by the node agent. Here we go. And now we see only this one unit which was added via operating system config was deleted, and the other ones, so the default unit and the one I created by myself, is still present on the node. Yeah, that's basically it. Any questions?
So I have a short question. So this basically means that we want drop-ins or unit files that are manually created also to not be removed, right? So I can imagine a scenario where someone, I don't know, messes with one of their machines and creates a system D unit that messes up some, I don't know, Gardener stuff, and then it can become quite hard to figure out what actually happens. Is that something we want, or do we not want that? I don't know.
I think this is something we accept, right? So because we allow the users to change the contents of the nodes, and might be for good, or it might be for bad. At least that's my point of view.
All right. Okay. Thank you.
Okay. Any further questions for this topic? Nope. Thank you, Oliver. And with this, we are also already at the end of today's occurrence. Thanks everybody for joining, and we will meet again next week for 1.112 release. Have a nice week. See you then. Bye-bye.
Bye-bye.
Bye bye.
Bye.
See you.
Bye. Thank you.
Bye.